Hello, everyone, and welcome back. As you can see, or as you can hear, my voice is on the fringe currently, so I apologize for any yodeling or hoarse moments that you might hear. Um, I am perfectly healthy and good to go. I just don't have much of a voice right now, so my apologies in advance. But luckily, today's class is really just some built-in time for you to practice finding the zeros of a function. And so our lesson for today is going to be very short. Um, it is going to have some time built in at the very end, especially for you to practice putting everything together that we have done up to this point. And then the reason why we are doing that is because if you check your course calendar, you will see uh, in the upcoming class periods, you have your test review day and then your actual test for our next two classes. And so please take advantage of today. It is a built-in day for you to really practice basically everything that we've done so far, and for you to just have some extra time to ask questions before your test review and before your test. So without further ado, let's go ahead and get started. This is just a warm-up to get us started for today, but it's also the bulk of what we will do today. You've got three functions on this slide, and I want you to work on finding the zeros of the function, meaning set your function equal to 0. Okay. Remember that find the zeros of a function are the same thing as find the x-intercepts, or find the solutions, or find the roots of a function. All of them mean set each function equal to 0. So pause this video and see if you can find the zeros of each of these three functions. Also remember that once you find your solutions, that you can graph them on your graphing calculator device and check to see if you got the correct answers or not. So go ahead, pause your video, and work through these three, and then we will reconvene. All right, so just to save my voice a little bit, um, but to also give you um, a thorough demonstration of how to solve these, just as a quick review, I recorded me working these out step by step. You'll also notice that I did the factoring method and I modeled the quadratic formula for you as well. We can definitely use the quadratic formula for this example because it is a quadratic equation, meaning its highest power is a 2. And you'll notice that regardless of which method I use for this function, I ended up with the same solutions. The two zeros, remember the highest power will tell you how many solutions or how many zeros you will have. But I ended up with those two solutions and they were the same regardless of the method that I used. I got my zeros to be x equals 2/3 and to x equal -8. Now, if I was to graph this function, I will see that this graph intersects the x-axis at 2/3, 0, and at the point -8, 0. And if you recall from last lesson, that is exactly what zeros of a function do. It is where it crosses the x-axis or where the y value of the function is 0. Okay, I'm about to clear the screen and I'm going to do the next function as well, and I will leave the recording going so that you can see me work through it using factoring and quadratic formula again. So again, you can see in this second example, because it is quadratic, meaning its highest power of the function is a 2, I can either solve for the zeros of the function using factoring, or I have the option to use the quadratic formula as well. Regardless of which method I use, I get the same 2 solutions. If the highest power is 2, that means there should be 2 solutions. And if I were to grab my graphing calculator device and graph 6x squared minus 7x minus 3, I would see that that graph intersects the x-axis, or has x-intercepts at negative 1/3, comma 0, and at positive 3/2, or 1.5, comma 0. Okay, last one, clearing the board. Here we go. And same thing with this one, we're looking for the zeros of the function. And so we would set this function equal to 0 and then solve for the variable x. If you were to graph this function, the square root of 3x minus 4, you would see that it intersects the x-axis at 16/3, comma 0. Okay? Or if you used a calculator, then some of you might have gotten 5.3 repeating, comma 0 for your x-intercept, or the 0 of your function. So remember, I said that the majority of today's class would be putting everything together. Well, last class we looked at the zeros of the function, but we also very briefly touched on increasing, decreasing, and constant functions. And we already discussed how to do that. And so this is just really giving you a little bit of extra practice, because again, we're trying to put everything together. So the answers are already up there at the top, and I'm less concerned about the answers and more about how do you write this. Can you write it out on your test? Because your tests are online, they're virtual. Can you type it out? Can you find the parenthesis symbols? Can you find the bracket symbols on your keyboard to submit your answers for your test? Okay, so, and it's funny that I said the brackets. You'll need that for your domain and range, but do you need brackets when you are writing out your increasing, decreasing, and constant intervals? You do not. You only use parentheses when discussing direction. And you hopefully remember that is because brackets are used when we are containing or including a value. Well, we cannot bottle or contain north. It is a direction that we point ourselves to, and then we travel a measurable distance. So when we're talking about increasing or decreasing, we can't bottle the amount of increasing. Okay? That is just simply a direction that we are listing. Okay? So pause this video and see if you can use that interval notation. Use those parentheses to write out where this graph is increasing, decreasing, and constant. Check your answers. Remember that when we write out our intervals for direction, we use the x values. So it's very similar to writing out the domain. And because if you think about it, the domain of this function is brackets, -2, comma 4 bracket. And if we put all of those together, we would reach that full domain. So just keep that in mind. That might be something that you need to brush up on and study, because it can get a little confusing. Domain is the x values, use brackets or parentheses. Range are the y values, use brackets or parentheses. Direction So increasing, decreasing, or constant is just parentheses using the x values. So you might want to make a note of that in your notebook or wherever you are taking notes, just so you can study that and make sure you are on the same page and you are understanding that well. Here are a couple more examples for you. I want you to determine, check out the wording here, determine the open intervals on which each function is increasing, decreasing, or constant, aka write out using those parentheses notation, where's my graph increasing, decreasing, and constant. One thing that I do want to point out to you, it's in a lot of textbooks. You notice how a lot of these graphs, they just look like they stop. So there's not an actual point graphed right here. It just looks like it cuts off. When that happens, you can assume that this just keeps going forever and ever. But it'd be different if there was an actual point right there. So if there was a point plotted right there, that means it stops. So kind of like this last example, you notice how there are solid points right here. That means that the graph stops right there. But on these, if you ever see something like this, then I want you to assume that those are arrows and that they keep going. Okay? And most of the examples, I would be so bold as to say all the examples that you will see on your test and on your assessments will have the arrows on them, just because I like to have them on there. But if you run into a situation where those arrows are not located on your graph, just think of it as the graph keeps going forever and ever, so at some point the printer has to cut off the graph. Otherwise it would keep printing one graph for eternity, to infinity and beyond, literally. So again, anytime you see something like that, assume that it keeps going. You can draw your arrows on there. Pause this video and write out the open intervals on which each function is increasing, decreasing, and or constant. Go ahead and check your answers. If you have any questions, make a note of these graphs in your notebook and contact me during office hours, or send me a picture of the specific one through email or through the Remind app. All right, we have reached the end of our lesson for today, and now we just have some practice questions for you. You'll see that there's quite a few on the screen here. This one is marked out for you, so don't tackle that one. This one over here, the numbers are kind of messed up a little bit. I will go back and renumber those if you'll just give me a second. But notice your directions. For 1 through 5 on the left, you're graphing the function and tell me the domain and range. You are evaluating each function. You're stating the zeros, and you're telling me where it's increasing, decreasing, or constant. On the right-hand list, you are just finding the zeros of the function. So if it is quadratic, then you can use the quadratic formula or factoring, or whatever type of function it is. Remember, your very first step is always set it equal to 0 and solve for the variable x. This concludes the end of your lesson for today. It's much more of a practice than it is new content, but that's a good thing. That gives you some more time to catch up if you need to, and practice this information before we build on top of it. So I'll be posting the answers to all of these with work shown. I'll post them as a PDF attached to this video assignment so that you will have the work shown and the final answers for you to check your work. And then if you have any questions about specific ones, you can contact me during office hours for those. Other than that, that is all I have for you today. If you need some assistance, please feel free to contact me to set up some office hours time so that we can answer any questions that you may have. Other than that, have a wonderful day, and I look forward to hearing from you soon. Please check your course calendar. I have a feeling that there will be a live class session next class for our test review, so just please be checking your course calendar to see that. And yeah, I'll see you then. Have a good one. Bye-bye.